Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A hydride shift is favorable when it relieves ring strain or converts a less stable carbocation into a more stable one. The driving force is both the stability gain of the resulting carbocation and any relief of angle strain. Moving on to the next step. Structure A shows a cyclobutane ring with a carbocation at a ring carbon adjacent to a carbon bearing a methyl group and a hydrogen. A1, 2 hydride shift from the adjacent carbon to the carbocation would open or rearrange the ring. Specifically, if the carbocation is at the ring junction and the adjacent carbon has a hydride, the shift converts the cyclobutane ring carbocation into a ring expanded carbocation or a more stable tertiary open chain carbocation, simultaneously relieving the significant ring strain, filter 26 kcal of cyclobutane. This dual driving force, ring strain relief plus carbocation stabilization, makes the hydride shift highly favorable. Moving on to the next step. Structure B is a neopentyl type tertiary carbocation. The carbocation is already tertiary, so there is less thermodynamic driving force to shift a hydride. The resulting carbocation would not be significantly more stable. Ring strain relief is not a factor here. And for the final step. Structure C is an open chain secondary carbocation. A1, 2 hydride shift would merely give another secondary carbocation, no gain in stability, or at best a similar secondary carbocation. No ring strain relief is involved, so the shift is not particularly favorable. Structure D shows a cyclobutane ring with an exocyclic secondary carbocation. While ring strain could in principle assist a rearrangement, the geometry and the fact that the carbocation is exocyclic, not at a ring carbon bearing a hydride that would lead to ring opening expansion in a productive way, makes the shift less favorable compared to A. Option A benefits from both ring strain relief of cyclobutane and conversion to a more stable carbocation upon hydride shift, making it the most favorable case. Therefore, the correct answer is A. Therefore, the correct answer is option A.